Hello and welcome to the KubeStellar community meeting for, I guess this is May 16th. So let's see. This is a CNCF organization. So we run by the CNCF Code of Conduct. And here we go. I guess I'll just read that out. As contributors and maintainers in the CNCF community and in the interest of fostering an open and welcoming community, we pledge to respect all people who contribute through reporting issues, posting feature requests, updating documentation, submitting pull requests or patches, and other activities. We're committed to making participation in the CNCF community a harassment-free experience for everyone, regardless of level of experience, gender identity and expression, sexual orientation, disability, personal appearance, body size, race, ethnicity, age, religion, or nationality. So in the agenda, we have attendees. Please add yourself. And now let's go through the items. So first one up is Paolo on the Argo CD workflow. So Argo Workflows.
Yeah, actually, it was KubeFlow pipelines. Sorry, maybe.
I'll fix that.
Yes, so let me start. I think I want to introduce a little of background first, the motivation of this work, and then I'm gonna go through a quick demo also. And the idea is really to show the capabilities of KubeStellar, especially some of the new features like custom transforms and how easy it is to set up somehow multi-cluster for existing projects, like in this example. So let me start sharing 1 second my screen. I think I have some little issue first to solve. Okay, here. Let me share my screen and just make this larger. Okay, so the topic is AI/ML multi-cluster KubeFlow pipelines with KubeStellar. As I mentioned, really the idea is to see how we can use KubeStellar with existing projects, in this case, KubeFlow pipelines, to enable multi-cluster execution across different clusters for this type of workflows. In terms of motivations, the idea is really be able to, for example, one of the scenarios, the ability to burst workloads from one cluster when I'm running KubeFlow pipeline, what we call here in this picture, the control plane KFP cluster, where I already have KFP, I'm already running some pipeline, and then I kind of run out of capacity. I need more capacity, and the way to get that is to add more clusters. I could do that also in theory, adding nodes, but sometimes there are limitations over that, especially in multi-region kind of scenarios, or also scenarios where I may have limitation on where data must reside. Maybe it has to reside on specific clusters. I can't bring data outside those clusters and so on. There are also scenarios where some of the clusters are set up with a particular type of accelerators. So it's more like a heterogeneous kind of scenario for GPU resources. And so these are just examples of where somehow having the ability to run workflows for AML and multi-cluster may be beneficial. The goal of this work was really to make this kind of running of multi-cluster pipelines completely as much as seamless as we can. So the idea is really be able to dispatch and execute these pipelines in a way that the existing tools, the existing UI, the existing CLI, they just work. I can just run. Even more importantly, my code is unmodified. I don't need actually to do any change for running in this type of scenarios. I can just run the existing code. Even the way I select, I put constraint on resources should just work the same way. I'm going to actually show an example of that in the demo. And the idea is really sort of a tagline that we like to have for KubeStellar. Just add KubeStellar and somehow make things work. There is, of course, some additional glue code, some additional work I had to do here, but the basic features really provided by KubeStellar enable this ability in a very seamless way. There is also some additional work we did in terms of somehow enabling somehow scheduling of workloads of these pipelines across the cluster. Eventually, the user can use manual selection, or also we add with some external additional component. We can also allow to select based on constraints on resource and also utilization of the resources. Before we go to the demo, maybe a little background on KubeFlow pipeline. What is actually a pipeline? It's essentially a description of machine learning workflows where all the components used in the workflow, the interaction are somehow defined. So there is some terminology here in KubeFlow pipelines. The main building blocks are really components that somehow embody the code that actually is used to run a particular task. And then these components typically run in containers. So there are containers to run the code. So typically OCI containers. And then there are graphs. Typically the pipeline is defined as a DAG, and the nodes represent the components where the code runs, and then edge represent the flow of the data between them. Some additional terminology is about runs. When you start an instance of a pipeline, as a user, you start a run. And this can be started manually or can be also triggered by events. Runs typically are grouped into experiments because maybe the user may tune some parameter and then make another run all as part of the same experiment. Here is a very simple example of a pipeline, a kind of hello world pipeline. As you can see, this is Python code. Typically, there is some DSL that is part of the KFP to identify what are the components, what is the pipeline, to identify the parameters that are passed. And typically, you may also add in the end the compilation of the pipeline into a YAML. And this is part of the way KubeFlow pipeline works, that when you compile and submit a pipeline, you have first to compile that. The compiler generates an output file that is YAML that is called an intermediate representation in KubeFlow pipeline v2. And from there, this output, this pipeline YAML, can be uploaded to the running KubeFlow pipeline system. And that will be at runtime compiled into the actual backend used to execute the pipeline. That in KubeFlow pipeline by default today is Argo Workflow. There is also an implementation, a backend that implements Tecton pipelines. But for this particular integration, we are mainly focused on Argo Workflow that is mainly used in V1, but also in V2 is probably the most common used backend in the community today. And now let's talk a little bit about the actual demo. What I'm gonna show. We have, as I mentioned earlier, there is a control plane cluster where we have installed KFP, KubeFlow Pipeline v2. And then to somehow simplify the integration, we added some additional components. I will describe the components on the control plane cluster later, but first let's just say that there are also these execution clusters that you see on the bottom, where also we've installed KubeFlow pipelines. And the clusters are all configured to share the same S3 repository. This is a repository used by KubeFlow pipelines to share artifacts and logs. There is also a repository, a database that is a relational database, typically is MySQL or Postgres, that is used to share metadata information about the runs. So things like run ID, status of the run, description of the pipeline, and some additional information that is basically providing status about the particular run. Now, going back to the control plane cluster, we have, as I mentioned, KFP. We have also added mutating webhook. And the main reason for that is that once KFP, as I showed earlier on, compiles the pipeline code, the KFP, the intermediate representation to the Argo Workflow format, it just applies that to the cluster. But pipelines, Argo Workflow pipelines have this nice feature that is suspend, the ability to suspend a workflow. So the mutating webhook is suspending the workflow, and this then allow us to, at this point, make a decision. The workflow just doesn't run when it's suspended on the top cluster, on the control cluster. And this is where we can come and make some decision. We can decide, well, this workflow should run here locally, and then, of course, can be unsuspended, or can be delivered to these execution clusters on the bottom. And in that case, before actually gets there, it needs to be unsuspended. How we deliver that workflow, Argo Workflows to the clusters here. This is all achieved using KubeStellar. KubeStellar has this ability to just using binding policies to essentially take a workload that is running on what we call the workload definition space based on labeling that identify, for example, labeling that identifies that workload, and deliver that workload to execution clusters, like in this particular case. And also, when we deliver one-to-one, when, like in this case, we want to deliver this workflow just to one cluster, we can report back the status as is updated downstream. The status from the workload is also updated back into the workflow that exists in the control plane cluster. And this is all controlled by these binding policies. In the particular setup I'm going to show here, there is a binding policy for each of the clusters, for each of the execution clusters. And also we set up in a way that we report back the status so that the workflow is updated. And from the point of view of KFP, everything looks good because mainly the tools in KFP are looking at the status of the workflow. And even if that workflow is actually executing downstream in those execution clusters and pods are created there, there is a very detailed status that is provided in the control plane cluster, in the workflow that the tools in KFP are using to basically report what is going on. There is some additional piece I'm showing here. For example, there is, as you can see, this multi-cluster scheduler. This is sort of an optional component that allows to essentially, as I said, make the decision about where the workload should run. Should it run on the control plane cluster? Should it run on this cluster below? Which cluster? This could be, for example, done looking at resource availability on the downstream clusters, looking at constraints on the availability of, for example, accelerators and so on. And this is pretty much what this scheduler does. It's a very relatively simple piece that integrates also with KubeStellar and provides essentially metrics to the scheduler. I mean, it uses metrics that also we propagate from the downstream cluster from the execution cluster to KubeStellar. And we use those metrics to make decisions, essentially, and constraints and other things like that. Taints, for example, is all part of the decision. There is also another piece here that I'm showing that is this shadow pod controller. This is essentially a controller that is also watching at the workflow status. And the workflow status will show which pods are being created in the execution clusters. And since KFP UI requires also the presence of pods on the control plane cluster to show the logs while a particular task is executing, we sort of mirror the pods that are created downstream on the control plane cluster. And these are really shadow pods because they are shadowing the pods that are downstream. They have the same name, the same namespace, and they are just essentially showing the logs. They are not really executing anything. They only exist during the duration of a task. And then when the task is completed downstream, Argo Workflow that is part of the KubeFlow pipeline automatically archive the logs into S3 in the shared artifact repository. And at that point, KFP just retrieve the logs in the control plane cluster used by the user, just using that UI. There is no need to, at this point, to have these shadow pods running anymore. The way the shadow pods work is really there is an additional infrastructure for collecting, aggregating logs that in this particular demo is Loki. And we essentially have this controller, the shadow pod controller, start each individual pod, and then each individual pod is connecting to Loki. It's been somehow primed, the pod has been primed in terms of environment with enough information to do queries to Loki to retrieve the log for the corresponding pod downstream in the execution cluster, and to basically print that log as the task progresses. So that is pretty much the architecture of the demo, and I don't know if there is any question at this point. Otherwise, I'm just gonna go and actually show how this is running.
Yes, remember we do have other items on the agenda.
Yeah, so the demo is about a couple of minutes, so I should be done pretty quickly. All right, so let's actually go to the demo. First, I'm gonna quickly show this is pretty much the code I'm going to run. As you can see, it's using the DSL, the preprocess, is using the component tag and so on. And at the end, this is actually defining the pipeline. It's a very simple pipeline. This is actually from the examples in KubeFlow pipelines. That's pretty much what I'm running. If I go ahead and I illustrate the typical steps that are done when running this pipeline, as I said before, the user first will compile the pipeline, just running Python data passing, etc. This will produce a YAML file that is, I think it's data passing. Let's see. There should be a pipeline. Let's see. Pipeline YAML, right? This is an example of this pipeline YAML that I have, right? And then the typical step at this point is to, we can use data the UI or can use the CLI to submit the pipeline. Let's assume that we're using directly the SDK to submit the pipeline. So I'm gonna submit the pipeline I just compiled. Actually, I have to add the number of runs I want to do. And then once this happens, I can go to the UI. I can do this, by the way, I can also do this from the UI, right? And the UI also have what I just did. I can also select a pipeline. I can start from here. I just wanted to show that this can be done either using the UI or just the existing UI, the SDK, right? So I can click then on the run. One particular run, I can see the graph, the DAG that is being created for that pipeline. And one thing I also want to show at this point is to show these terminals. I have 3 terminals. One is showing pods, as you can see in this command, continuously showing pods on the control cluster and pretty much connected there. And then you have these other 2 screens. One is for cluster 1 and one is for cluster 2, all in the same namespace. I can see that pods are being created in the execution cluster. In this case, the scheduler picked up cluster 2, and I can see for that particular run, a number of pods are being created. And the ones I see on the top are these shadow pods, right? They are essentially providing the logs for the UI. If I go back to the UI now, I can click on any of the tasks, for example, this task here. There is a lot of information provided about the data that is exchanged, that is passed by this task as input output. And also this data is stored into S3. In this particular case is min.io in my demo. In this case, it's just passing hello world as a output. There is some more information about the task, and then also I can see the logs, right? The log, this is actually coming from a shadow pod. I also added here some information about the context. This is about the cluster 2. But there is also a log for a long-running task that is this train that is just doing a print to simulate is actually running some training, right? So this, again, there is some context here. This is cluster 2, but I can see that there is also some print here. And this is periodically updated and refreshed. So eventually this will take some time to run. But again, it's a simulation. It's not really running for real. And that's pretty much it, right? The idea is to show we can essentially use the existing tools, the UI, the CLI, from KFP, the SDK. Everything works pretty much the same way. But now these particular runs are dispatched to remote clusters for execution. So this is pretty much what I wanted to show. One thing I wanted to add also is that we're gonna also post some. I'm working on some blogs also for this work, and we just also made public a new repo called Galaxy under the KubeStellar org, where we are storing some of these scripts and glue code for some of these integrations. So folks can go to this repo and just run the scripts, and pretty much the setup I just showed come up, and you can just give it a spin. That's pretty much the idea. Okay.
Thank you. Yeah, okay. So yeah, that I'm wondering, should we actually make a separate agenda item just as a matter of recording the announcement of that new repo? Why don't you make it just an agenda item, just record the fact that you announced that new repo.
Okay.
Thank you. And that's also a note to Kevin about the website. All right. Next up is the interns for open source. Andy is sick today. He didn't want to talk, but he is the expert on this. So I can just read the information from the agenda, or I mean, everybody can read it themselves. We have some interns in progress. I'll leave it there. New blog posts. I think that's a prompt. Does anybody here have anything they want to say about new blog posts?
Yeah, Mike, I just mentioned earlier on, I start working on a couple of blog posts. So the first one is gonna be on the integration.
All right. I didn't want to ask you to repeat yourself. Is there anything else that anybody wants to say about that? I'll take that as a no. All right. Thank you very much. Okay. KubeDay Japan. Well, this is a prompt for Yana, who is not here, but apparently there is a CFP in progress. I don't think we had anybody here who knows anything more about that. All right. Let's move on then. We do have the North American KubeCon coming up. So reserve your hotel. And we do have 6 CFPs in progress. And let's see, again, is there anybody here who wants to say anything about them, anyone's in particular?
Yeah, I can comment. At least for my side, I planning to submit one proposal for a talk on the work I just showed for the integration with the KubeFlow pipeline. And we've also been discussing about submitting one for specifically for KubeFlex. Maybe we can try to pursue not just the use case of running KubeFlex for KubeStellar, but looking also at potential use cases. So we've been talking about this idea of this new cap for building API servers, custom build API servers, and maybe KubeFlex could be an interesting platform for that. It could be potentially another topic for a talk on KubeFlex.
Yes, I agree. The cap for factoring the Kube API server to expose the library for convenient or easier building of other API servers has been accepted, and the work is in progress. There is a tracking issue, I think, in Kubernetes. I'll update the agenda with a pointer to that.
Thank you.
Okay. But yes, the KubeFlex adds another layer to that, which is something to it's more than that. Or a separate issue, which is it's about virtualization and hosting.
Mm-hmm.
So there's it is its own content there. Okay. Let's see. Andy also says he's gonna submit one about the blue-green Canary deployments and the interns for open source. I don't know, Andy, if you want to try to speak to those right now.
Yeah, Mike, it's just straightforward. Interns for open source, the 4 folks that we have working with us this summer, just seeing if it's something of interest to others that are looking for the same type of, exchange of experience in open source for college credit. And Blue Green is something I wrote up a couple months ago using KubeStellar to deliver things like configuration for DNS and so forth, and being able to switch sites on and off for availability's sake. So that's work that I did a couple months ago. So I'm hoping to submit both of those. IFOS would be a panel with potentially with the folks from Georgia Tech and Valencia attending. I think so far I have commitment from Valencia, trying to get commitment from Georgia Tech to attend. So we'll see how it goes. Thanks.
All right, thank you. All right. And I don't think we have any other representatives available to talk right now. Okay, so let's move on. For development, we did get the 0.22.0 release out. We're working on the next one. The highlights of the goals for that is work on Helm charting to make it easier and simpler to deploy and use KubeStellar. Improvements to the website. Kevin is looking at overall reorg. It could really use that. And we have Braulio, who is planning on doing some performance testing. And I think we should, that will, I expect that will benefit a lot from certain functional improvements. So I'd like to get that in the next release. I'm thinking specifically of making our controllers offer Prometheus metrics, the debug pprof endpoint, and take controls over the client library self-restraint that's in the Kubernetes client libraries. If anyone wants to say anything more about goals for the next release. Okay. Let's see. Next item here is about Braulio's testing. He is working on a performance/scaling test plan. He's not here to talk about it in detail. So let's see. Well, actually, he's a couple of things. The agenda seems to be focused on this soak test or performance test. He's also looking at scale testing. These will all be, I think, great in informing us about what we've got. Let's see. Next item, I think this is an old one about decoupling KubeFlex and KubeStellar. I don't know if there's any news on that front. Anybody here have any news on that front?
Yeah, I don't think this came back. I think we had some discussion lately with Ezra where we thought that there is probably still value to have a KubeFlex in the picture, but we haven't really discussed about just running a KubeStellar without KubeFlex at all.
Okay.
That was one topic that we've been discussing, but then I think Ezra was somehow changing his mind on that. But probably something we can bring back in terms of discussion.
Okay. Yes, I still think there's value in having them having greater modularity. All right. Since he's not here, we can't really have the conversation. All right. Let's see. Next item. Oh, this the Helm charting work. So Franco, do you want to say anything about that?
Sure. Can I share my screen for a second?
Yes.
So I would like to highlight that there is indeed a PR 2157 that tries to create the first comprehensive hub chart for KubeStellar. This chart aims at automating the installation of KubeFlex and its requirement, in particular Postgres. It allows the user to install the appropriate post-create hooks that are used by KubeFlex to customize the control planes, in particular the ITSs and the WDSs, and allows a user to create a user-defined list of ITS and WDSs and appropriately connect them together. It's a pretty large PR. If we look at the key file changes, we see that there is a new folder called Hub Chart that contains a new chart. We also provide a convenient script for creating a kind cluster, since now that becomes a prerequisite. And in the documentation, I would like to point you to this particular file, the Hub Chart MD. Which contains a pretty detailed information about the capability of the Hub Chart, the various values, how to deploy the chart in an existing cluster, being a kind cluster or an OpenShift cluster, as well as how to obtain the control plane configuration without currently the need of KFlex CLI. There are still updates going on. This is not finalized, but it's under review. So if there are potential users that would like to use this chart, this is a good time to provide some feedback on features and what will be required. That's all.
All right. Thank you very much. Yes, I heartily encourage people to review that PR. I'm doing that myself, and I do hope that we can get it merged. It is a big PR, so just in terms of cross-section for interfering with other work, I would like to get that merged as soon as possible without prejudicing against follow-on work. So I think this is, as I said, it's one of the goals for the next release. I think it's going to be an important improvement. All right. I think we've run off the end of our agenda. Does anybody have anything else they want to add? All right, then. I think we're done for the day. Thank you all very much.
Thank
Thank
you.
you.
Okay, bye.
Bye.